Hello everyone! Today we're excited to introduce Signify, a mobile app for sign language learning and communication aid from our Capstone team. Our team consists of 7 people from 3 different paths. From cloud computing, there's Akmal and Septian. In mobile dev, there's Daniel and Septian. And lastly, there's me, Agnes, Natasha, and Nicholas from machine learning team. Next, let's see the background of our app. In 2020, statistics showed that there are more than 900,000 Indonesians live with a hearing impairment. Therefore, it highlights the need for greater accessibility in communication. This is also supported by Indonesia's law number 8 of 2016 that protects the right of people with disability, ensuring that they have the same opportunity as everyone else. It aligned with our application objective, therefore we designed not just a learning tool, but also a bridge to improve communication between the hearing and non-hearing communities. As for the sign language system used in our app, we follow the CB, short for System Based Indonesia, and the dictionary is here. It was standardized by the government on June 30th, 1994, under the Minister of Education and Culture's decree, and is widely used in special needs school. By adopting this, we ensure that Signify is a trustworthy resource for anyone looking to learn or communicate using sign language, specifically for the alphabet.
Despite advances in technology, real-time apps for sign language learning and communication are still limited, leaving deaf individuals struggling with daily communication challenges. Our app was created to address communication gap between hearing and non-hearing communities. Its purpose focuses on three main goals: bridge the gap between hearing and non-hearing communities, enable inclusivity through interactive learning, and encourage societal awareness and adoption. The similarity between our app and Handtalk or Lingvano is approximately 66%, while the similarity with Science School is about 44%. Our app Signify stands out in the sign language learning space by integrating features that balance both learning and real-time communication. For example, Lingvano has quizzes for practice sign language but lacks of real-time camera detection. On the other hand, Handtalk offers camera ASL detection but doesn't have quizzes for practicing. Signify bridges these gaps by offering both features, making it more complete solution for learning and using sign language.
For the implementation, Signify leverages advanced technologies to provide a seamless experience. On the mobile development side, we have designed an intuitive interface with features like quizzes and interactive listen. On the machine learning side, we have integrated a real-time camera detection feature that allow users to recognize and practice signing alphabet letter accurately. Lastly, the cloud computing team ensures the app operates reliably by hosting machine learning models and user data securely on Google Cloud, guaranteeing accessibility and scalability.
For the machine learning process on making the model, we start by collecting the dataset for every letter. We use two datasets from Kaggle, but we also add our own dataset. Altogether, we compile approximately 3,000 images for 26 alphabets. Next, for pre-processing, we use the open-source MediaPipe Hands framework to extract the hand landmarks from the dataset. These landmarks include both hand with x, y, and z coordinates for each key point. After that, we design the model to take two inputs, hand landmarks and image data, and we use a convolutional neural network to process both inputs. Output is the predicted class which corresponds to the letter being signed. Next, we were able to achieve 98% accuracy on our model within 15 epochs. As you can see, this is the visualization of the training history of the model. The accuracy graph shows a steady increase in both training and validation accuracy, and the last graph demonstrating that the model learned effectively without overfitting.
In here, the cloud computing infrastructure included create database service such as Firestore and cloud storage for data and user history application. API development service for building the backend infrastructure, Postman for API testing, Gemini for AI for auto-correct integration, CloudRAM, App Engine, and artifact registry for deployment fields. And then here there is called computing workflow. Start with login in the application and accept the authentication. And then the authentication is processed on Firebase for save the user data with authenticating. Continue on the main page. The user can choose the quizzes or lessons menus for understanding study flow. We use Express.js for API development for quizzes and lesson tasks, and App Engine for API production, Every user who has completed one of the tasks in the menu, their story is entered into the database. Then, user can choose hand gesture prediction. Here, our model is deployed to the cloud using Fuzz API for API development, Artifact Registry for Save Docker Image, and Cloud Run Container for API production. And its output is prediction result, timestamp, and image with landmark are stored on the cloud storage.
For mobile development implementations, these are the tools that we have used. First of all, Android Studio, Kotlin, and Jetpack libraries, such as Camera X, View Model, Coroutines, and many more. And also, this is the application results for our main feature. User can capture the hand signs which are sent to the cloud for processing, response or return, and a finish button allows the user to revise the detected text. Built-in Gemini autocorrect feature, then the final results includes options to text to speech, enhancing accessibility. For our improvements, we are going to implement a ROM database to minimize reloads, simplifying and optimizing coroutines for following the best practice, enhancing memory management to prevent application not responding issues.
Hello! Today I'm going to introduce you to our app, Signify. The first, we're going to see the onboarding screen, and then we'll move on to the login and registration process. For registration, you can input the required details like email address, name, and password, but make sure it's at least 8 characters long. After that, we can click the register, and we can use the same details like email address and password to log in our app. And then we can click the login button. Once you've logged in, you're gonna see our home screen, where you can see the latest news about sign language, and then there's the lesson and quiz tracker on top, and on the bottom part, you can access different sections of the app. Next, in the lesson section, we're going to see some of the lesson there, and then we're gonna click on the first lesson. Each of the lesson includes a tutorial video, where we need to watch the video fully before we can move to the next step. Because skipping the video means that the lesson will not be marked as complete. And for this demonstration purpose, we're going to fast forward. And then you can see the status is now completed. Now we're going to go to the quiz section. We're going to click one of the quiz, and if you answer incorrectly, there's going to be notification and sound effect. And correct answer will also trigger a success sound. Now let's move on to the camera function, where it allows you to detect CB alphabet sign language. For the first example, we're going to try to type Bangkit correctly with the gesture. We're going to try spelling out each of the letter with the proper hand signs, as you can see here. After that, we click Finish. And as you can see, it spells out Bangkit. You can also use text-to-speech features. And for the second example, we're going to try out the autocorrect function. When there's a typo while signing, the app's supposed to detect and correct the typo. For example here, we want the output to be hello there. But we're going to put some typo in the middle of signing. As you can see, we put R in the middle of T and H. And we see if the app will fix the typo or not. After we finish, we're going to see the output is hello there, and we can test out the text-to-speech. That's all from us. Thank you for watching, and we hope you enjoy using Signify.
Timeline. In January, we focus on planning, developing strategies, and setting goals. February is for refining the app's design and performance. March involves testing with target users to ensure accuracy and usability. In April, we finalize the app for public release. By May, we launch and promote the app. Finally, in June, we review the launch and gather user feedback for future updates. Budgeting. Our total budget is around $10,000. Target market. Our app target individual aged around 17 to 35 years old, especially student, educator, and public service professionals. It appeals to language enthusiasts, volunteer, and tech-savvy user passionate about bridging communication gaps.
Thank you for your time and support. Let's work together to make communication accessible for everyone.